Okay, we are in 3.9 on page 28. This example says one train travels west towards Denver at 120 miles per hour, while a second train travels north away from Denver at 90 miles per hour. At time t equals 0, the first train is 10 miles east and the second train is 20 miles north of Denver Station. Calculate the rate at which the distance between the two trains is changing at time t equals 0. So a lot going on in this problem. First of all, there is a diagram, so that hopefully that helps kind of visualize it a little bit better. We have to think of something, a formula for this, in order to relate x, y, and L. It wants to know the distance between the two trains is changing. That's asking for us to find the rate, so that's dl dt. Dx dt and dy dt are how fast those trains are going. We have to take in consideration the distance, and if it's getting larger or if it's getting smaller, that would make that rate get either positive or negative. So first thing is I need a formula in order to relate x, y, and L. We're going to use our Pythagorean theorem. It's one of the big ones that we use in these. So we have x squared plus y squared equals L squared. And we're asked to find dl dt, but we know dx dt and dy dt. So let's go ahead and look at dy dt first. So y is the train that's moving north of Denver, and that train that's going north of Denver is going 90 miles per hour. So 90 miles per hour. And dx dt, the train that is moving towards Denver is going 120 miles per hour. Now the value of 120 miles per hour is actually negative. So I'm going to go ahead and put a negative sign on there. And the reason why is because that distance, it's getting smaller as that train is approaching Denver. So that distance is getting smaller. And that symbolizes a negative rate. Whereas the train that's moving north is moving away from Denver and that distance is getting larger. So dy dt is 90 miles per hour and dx dt is negative 120 miles per hour. So we are asked to find dl dt when it says at time 0 seconds or hours. So when t is at 0, we know that x is equal to and we know y is equal to. So x, it says that the train was 10 miles east, so we're at 10 miles. Y was at 20 miles north. And I'm going to have to figure out what L is. So in order to figure out what L is, I'm going to go ahead and set up a triangle over here. I know that x is 10, y is 20, and I need to find L. This does make a right triangle, so I'm just going to go and substitute these values in to my Pythagorean theorem. And so we have 10 squared plus 20 squared equals L squared. In solving this, you get L squared equals 500. So L is equal to the square root of 500, which simplifies to 10 square root of 5. So we know that 10 square root of 5 is equal to L. So the next thing we need to do is we need to take a derivative of our formula in order to get those rates involved. And our formula up above is x squared plus y squared equals L squared. Nothing is constant. Everything is a variable. Everything's changing as time elapses. So taking a derivative of 2x with respect to t is going to become 2x dx dt plus the derivative y squared with respect to t is going to become 2y dy dt equals the derivative derivative of L squared with respect to t is going to become 2L dL dt. So from here, we have a bunch of variables we can plug in. First thing though I'm going to do is just divide everything by 2, and those 2's would cancel out. So we have x, our x value is 10. Our dx dt, and I'll cross out the 2's just so we see that. If you divide all your terms by 2, those are gone. dx dt is negative 120 miles per hour plus y. Our y value up ahead is 20. dy dt was 90 equals L, which is 10 square root of 5, times dL dt, which is what we are looking for. It's our unknown. So going ahead and solving this for dL dt, we have 10 times negative 120 plus 20 times 90 divided by 10 square root of 5. And this, if you go ahead and simplify this, you will get 60 divided by the square root of 5. If you want to rationalize it, you can, but definitely not something that is required. This is a rate, and the rate that we have going on is L is a distance, and we're measuring that in miles, and time is in hours. So this is miles per hour. And so the trains